All right, let's now talk about energy and temperature. First, a couple of terminologies that we need to be familiar with because it's something we use a lot. The word system, when you say system, okay, we mean anything that we're interested in. So anything we're talking about is called a system. And so typically in chemistry, our system would be a sample of matter, a collection of atoms or molecules. Okay, everything else is called the surroundings. So if it's not the system, what everything else would be the rest of the universe. Okay, so you might say you can have the immediate surroundings of the system would be the, like if you have a beaker with a reaction mixture, if that's what your system is, then the immediate surroundings would be just the air around it in the lab. Okay, the word thermal energy, okay, you may have associated that to be synonymous with heat. The precise definition of that is really just the sum of the kinetic energies of the atoms in the system. So you have a collection of atoms, a sample of matter. If you add up the kinetic energies of the atoms in your system, you have what's called the thermal energy. Okay? Now, thermal energy is an example of what's called an extensive or extrinsic property. What that means is it's directly proportional to the amount of sample. What does directly proportional mean? You have correct. So the more sample you have, if you imagine you were to duplicate your sample, then you'll have twice as much thermal energy because you have twice as much sample. Okay, so that's what direct proportion means, right? So thermal energy would be directly proportional to the amount of the sample. It's an extensive property. Okay. Now temperature, there's a difference between temperature and thermal energy. Temperature, qualitatively in layman's terms, you can think of that as a measure of the hotness of an object or a sample, right? So that's why you measure in degrees. The level, you can say the level of hotness. And so it's actually not the same as thermal energy. It's a measure of the average kinetic energy of the atom in the system. So if you add up all the thermal energy, if you add up all the kinetic energies, okay, and then take the average, then that gives you the temperature, a measure of the temperature. Okay, not exactly the temperature, but it's a measure of the average kinetic energy of the atom. So it's not the same as thermal. So temperature is an example of what we call an intensive or an intrinsic property. So it doesn't matter how much sample you have. So for example, let's say imagine you have a beaker of water. Okay, let's say you measure the temperature of the beaker of water. We're at room temperature, so let's say it's 25 degrees Celsius. Now imagine you have a duplicate, two of those. Will it be twice as hot? Still, both are still be at the same temperature. Okay, so temperature would be an example of an intensive or an intrinsic property. Anytime you average something out, since you're always going to divide by the total number of atoms when you take the average, then what comes out is not going to depend on how much you have because you're always going to divide by the total amount, right? So temperature is an example of an intensive property. Okay, so now let's see the difference between those terms and the term heat. Heat, the precise definition of heat is that that's actually the energy that you transfer when you put something hot in contact with something cold. So it's energy that is transferred between, you can say, a system and its immediate surroundings when they happen to be at different temperatures. So it's a transfer of energy that results when two things in contact are not at the same temperature. When you put something hot next to something cold, then energy transfers from hot to cold. That energy that's transferred is called heat. Okay? How do we interpret that in terms of what's going on at the atomic world, in the atomic world? Because this is chemistry. We want to be able to interpret everything in terms of what's going on with the atoms. Why does heat go from something hot to something cold? Why does the hot object get cooler and the colder object get warmer when you put them in contact? Here's the explanation. The hotter object, the atoms have a higher average kinetic energy, right? Remember, temperature is a measure of the average kinetic energy. So heat flow is really nothing more than a redistribution of the kinetic energy because of random collisions. So So all these atoms in your sample and in your immediate surroundings, they are all moving. They all have kinetic energy. So the hotter atoms simply have higher kinetic energy on average. Okay, higher average kinetic energy. The colder atoms, the atoms in the colder system, would have lower kinetic energies. Because of random collisions, by collisions, energy gets transferred. Okay? So, the average kinetic energy, essentially what happens when heat flow, this is what happens when heat flows. The kinetic energy drops for the atoms, the average of the kinetic energy drops for the hotter atoms, and the average of the kinetic energy increases for the atoms in the cooler object. So this should be increases. Okay? Until the average energy is the same for both, and then in which case they have the same temperature. And you say you've reached what is known as thermal equilibrium. Okay? So if the two things are the same temperature, you say you have thermal equilibrium. So this happens until thermal equilibrium is achieved. And that's when the average kinetic energy is the same for both the originally hot and the originally colder object. When they come to the same temperature, they now have the same average kinetic energy. So let's look at this example right here. Sample A is 5 grams of copper at 50 degrees. Sample B, 10 grams of copper at 50 degrees. Which one has a higher average kinetic energy? Average? It's a measure of, what's a measure of average kinetic energy? Same temperature, same average, right? So, neither one. Which sample has more thermal energy? This would be sample B. It's like saying you have 5 kids versus 10 kids. Okay? And they all have, let's say the average money of the 5 kids is $10, and the average money of the 10 kids is also $10. They have the same average, right? But which one has more money? Well, 5 times 10 versus 10 times 10. Okay, this would be the 10 kids, right? They have more money. All right. Will heat flow between samples A and B? Well, the rich kids give their money to the poor kids. Same temperature, there's no heat flow, right? No heat flow, you're looking at the same temperature. Good? Alright, 5 grams copper versus same thing? Oh, this is different. 5 grams copper at 50 degrees, 5 grams copper at 100 degrees. Which has higher average kinetic energy? Sample B, because higher temperature, right, means higher average. Which has more thermal energy? Same mass, okay, but which one has a higher average? B. So I have, let's say, 5 kids with an average money of $5 per person, and versus 5 kids with an average of $100 per person. Which one has more money? Sample B. Okay. Is there going to be heat flow between samples A and B? Yes, because the temperature is not the same. Which direction does heat flow? So from B to A. Heat will go from B to A.